Okay, so let's start with number 1. This is worksheet 4. Okay, so first thing we want to do is, well, all these terms are going to be eventually relying on power rule to find our derivative. So many of these terms require a rewrite before we can apply power rule. So let me point out a couple of things that we want to do. We want to make sure we convert radicals to rationals. We want to be able to distribute the 7x cubed through so that we can be rid of the parentheses because we can't do power rule when there's parentheses in the way. I mean, we could do product rule, but I want you to go through power rule here. There's a fraction here. We could do power rule here. That's not an issue. I think it's just visually, some students have trouble with that denominator number. So I like to push that out as a number in front instead of a number below. This feels more consistent. You don't have to, but I think it's helped with students seeing what to do. And then we definitely have to rewrite this radical here. And then we have to rewrite the radical here and bring it up as a rational exponent. So a couple of those things we need to do. So let's try that. Okay, so I'm taking a couple steps here to get there. I definitely have that 1/11th pulled out in front. X cubed root of x is x to the 1/3. Square root of x to the 7th, right? This is not x to the 1/7. It's not 2/7. It's 7/2. And when you bring it up, it becomes a negative exponent. Okay. Still in the cleanup stage here, I'm distributing the 7x cubed through. And as I do that, make sure that you're not multiplying exponents, you're adding exponents. So 3 plus 1/2, the same thing as 6/2 plus 1/2, which is 7/2. So now every term should be ready for power rule. And now we can move into our power rule derivative stage. Any questions so far? Okay, so derivative, we bring down the 7/2 and we subtract 1 from the exponent. So that minus 2/2 is just to indicate that I'm about to subtract 1 from that 7/2. And then we repeat that process for every term. So 7/2 comes down, 7/2 times 7, x to the 5/2. This is 21x squared. This is 2/11 times x. 4 pi x becomes 4 pi. 5 pi to the 4th is just a constant that goes to 0. Bring down the 1/3, 1/3 x to the negative 2/3. Bring down the negative 7/2. Negative 7/2 times 5/2 x to the negative 9/2 because we have to take that starting exponent and subtract 1 from it. Okay, so this is our derivative. We still have to do a little bit of cleanup, but this is the most important step here, trying to get to that derivative correctly. Okay, let me pause for a moment here. Any questions about any of these steps here? Okay, so now clean up. Merge some of the coefficients together. And if I see any leftover negative exponents, I'm going to push them back down to the denominator. I'm leaving my answer as rational exponents, but if you want to bring them back in terms of radicals, that's fine as well. It's up to you. We're okay with one. Any questions here?
Wouldn't the 49/2, wouldn't that turn into root x to the fifth column?
You can, but you can leave your answer as radical form or rational. If you put it back in terms of radical, no issues there. Okay, number two, we have our function x squared over x minus 1, find f prime. So here, there's numerator and denominator. You see how there's more than one term in the denominator? We can't split this up. We can't do power rule. We're forced into having to go through quotient rule. All right, so find f prime. We'll do f prime using quotient rule. Make sure you know your product rule and quotient rule. Product rule is f prime g plus fg prime. Quotient rule is f prime g minus fg prime all over g squared. So after we have our derivative, then we can focus on writing our tangent line equation. We're going to have to gather our order pair from our original function, our slope from our derivative, and then finally put it all together in slope form. So my top portion is my f, bottom portion is my g, and I'm just filling in what I need to build out quotient rule. F prime times g minus f times g prime all over g squared. Hey, don't forget about g squared. A lot of times I see students forget about that portion of quotient rule. And as you clean up, most of the time, your denominator is not going to be changed. It's just going to stay what it is. It's just really the numerator that needs to be cleaned up. So we want to distribute the 2x through and then just do a little bit of cleanup before it makes it a little bit easier to plug in. So I distribute the 2x through. I get 2x squared minus 2x minus x squared. Combine like terms, and here's my f prime. Okay, there's my simplified f prime function. All right, so this is really the only calculus part of the problem here. Any questions up to this point? Okay, from here, it should be pretty straightforward. You're just plugging in values into the function, into the derivative. The function will give you your y value. The derivative will give you your slope. So -1 then for x of my function, I get -1 quantity squared over -1 minus 1. I get -1/2. That's my order pair. -1 comma -1/2. Slope, -1 then for x. I get 1 plus 2 all over -2 squared. So that's 3 over 2 squared. That's 3/4. So there's my order pair. There's my slope, and then point slope form. Okay, no questions so far. All right, number 3, find the derivative of f of x. Notice that this is set up as parentheses times another set of parentheses. I mean, we could fold all this out, but we're going to practice here going through product rule. You don't have to clean anything up once you find the derivative. Once you find your derivative, you can just leave them all in that one big mess here. And just being able to find the derivative, that's the important part. I'm just rewriting this slightly to get that radical to be rewritten. This is x to the 5/2. I'm going to call my first parentheses my f function. I'll call my second parentheses my g function. And we're just going through here, f prime times g plus f g prime. X cubed becomes 3x squared. This term here, we go through power rule, bring down the 5/2, subtract 1 from the exponent. Keep the g function. We don't find the derivative just yet. And then f, we keep that f portion. And then the derivative of 2x minus 5 pi cubed plus 7 is just 2, because 5 pi cubed, pi is just a number. So this is a constant that goes to 0. 7 also goes to 0. So only thing that comes out of g prime is just that 2. Okay, back page whenever you're ready. Everybody good? First page. Okay, particle moves along the x-axis in meters so that at times t is greater than or equal to 0, its position is given as x sub t. So we're units, it's meters and seconds. Okay. All right, find the velocity and acceleration function. Derivative. First derivative would be velocity. Second derivative will be acceleration. Okay, I want to save this spot for part K because there's another part that I want to deal with you, but we'll do that at the end. Just want to make sure there's a room for that. Okay, any questions to find velocity and acceleration function? You guys good? Power rule. Okay. All right, so now part B. What is the velocity at t equals 2 seconds? This is instantaneous velocity. We're going to use the velocity function, plug 2 into the velocity. This is a moment in time, so we can use our velocity function. Units of measure, meters per second. What's the acceleration at 4 seconds? We can, this is a moment in time, we can plug 4 into our acceleration function. Acceleration has a different unit of measure than velocity. Meters per second for velocity, meters per second squared for acceleration. Okay, at what time does the particle change directions? We're going to create our velocity sign line, but first we have to find out when the particle is at rest so that we can populate our sign line with critical points, and then we can test each subinterval. So first things first, let's set our velocity equal to 0 and find places of rest. Okay, factor out of 3. Okay, we set each parenthesis equal to 0. We don't have to worry about that 3 unless that was a 3t. If there was another t out here, then we will set that equal to 0, but we only care about solving for variables. There's no variable out here, so we only have to solve for t minus 3 and t plus. We set each piece equal to 0. We get t equals 3 and t equals -1. And we keep both of these t values. Okay, why not the -1? And why else? So, sometimes the -1 can work, but what is it that tells us to not use -1? Yeah. So sometimes the problem will say, for all real numbers. If that's the case, then we do want to keep the negative. But so we only want to take something out if we see that there's a restriction that is removing that extraneous t value. Okay. So because of that restriction, so here's my velocity sign line. We're going to include 3 on our sign line, but we're also going to include 0, not because that's a place where velocity is 0, but because that's a starting point for our sign line.
Even if there were like two numbers, but you still use 0?
Yes, assuming that t is greater than or equal to 0. But if this for all real numbers, then you would just use these two numbers and no 0. Okay, we're going to test each subinterval. I'll test 1, and I'll test 4. Okay. All this goes into any of the velocity functions, but I like to put it into the factored form. Easiest without, it's easiest calculations without a calculator. That's the easiest one to do. Okay, so 1 in for t, I get 1 minus 3, which is negative. 1 plus 1, which is positive. Negative times positive is negative, so I know that in this first interval, that negative indicates this particle is moving to the left. All right, plug 4 in. 4 minus 3 is positive. 4 plus 1 is positive. 2 positive makes positive. So after 3 seconds, it's going to stop at 3 seconds, turn around, and move to the right. And then we're not going to use these numbers anymore if there's any statements about intervals left and intervals right. Okay, so at what times does the particle change direction? We can say just at t equals 3 because there's a change in signs. You don't have to specify the direction or the order of sign change. You can, but you don't have to. Change signs is good enough. Part E, at t equals 0, is the particle moving to the right or to the left? So what can we do? Plug 0 into what? Velocity, yeah, because so if I plug 0 into velocity, 0 minus 3, 0 plus 1, I get a what? Negative. So therefore, moving left.
Could you also just look at the line graph? See that at 0, it's 112.
Yeah, but it's nice to confirm, right? Since the negative is just from 0 to 3, it's nice to confirm that at 0 that it's still moving left. So if we can go up to the saved space that I have for K, can we find intervals of moving left and moving right along with justification? Okay, so intervals of moving left, what would you say when is the particle moving left? 0 to 3, and then what are our notations here? What's that 0? There's going to be a what there? Bracket, yeah. Our justification is because velocity is less than 0 or negative velocity. And then we can say moving to the right. Interval from where? 3 to infinity, right? And we don't use the test numbers, right? Don't involve 1, don't involve 4. You're just using what you find with velocity when you set velocity to 0 and your starting point and infinity. All right. Any questions? Top half of the page. Okay. All right, part F. This is a trouble spot for some students here. Find the average velocity of the particle from 1 to 3. How do we define average velocity? Change in position divided by the change in time. It is just the slope of the position function. We don't touch the velocity function. Sometimes I see students doing slope with velocity. They would do v of 3 minus v of 1 over 3 minus 1. That's something else, right? We want to use, we're not going to use velocity at all. Okay, so it's position. So you'll find x of 1. You'll find x of 3. So we insert 1 into our velocity function. Get 1 minus 3 minus 9 plus 2. Okay, plug 3 in, we get 27 minus 27 minus 27 plus 2, which is negative 25. And that's all we need to find average velocity. Okay, so the change in position divided by the change in time. And even though we never touched velocity, our calculation is still, the units is still going to be in terms of velocity. Okay, part G, what's displacement from 1 to 4? Displacement, think of the displacement as just the numerator of average velocity. It's just the change in position. Final position minus initial position, and that's it. Okay. If you get a negative number, that just means that you end up to the left of where you started. If you get a positive number, that means you end up to the right of where you started. Okay, so x of 4 is negative 18. X of 1 is negative 9. And it's just x of 4 minus x of 1. Displacement is related to distance, so it's not meters per second, it's not meters per second squared, it's just meters. Okay, any questions up to this point? Okay, let's talk about total distance. Total distance feels like displacement. It's just a little bit more involvement than displacement. You're still going to gather the same information in terms of finding the starting point and ending point, position-wise. We're not going to do anything with velocity. Displacement and distance is, we're just relying on position or the pairs the entire way through. So we're going to use x of 1, because that's the starting point. We're going to use x of 4, which is our ending point. But we may have to involve a point in between, and we only have to involve a point in between if there's a change in direction. We got to rely on our number line here. Does this particle change direction somewhere between 1 and 4?
Yes.
Where?
3.
3. So we also need to find his location at 3. We need to figure out when is he going to actually turn around? Because we have to have another set of calculation from that point. So we can plug 3 into our function, and we already have that from part F, right? X of 3 is negative 25. Right, so I want to make sure that we understand what these numbers mean. These are actual places on the x-axis. And imagine yourself walking from one point to the next, and you're just counting your steps. So you start at negative 9, you walk to negative 25, and then you walk back to negative 18. And every step you take, you're just going to make an integer progress. So first thing is I'm going to walk from negative 9 all the way to negative 25. So how many steps does it take for me to walk from this location to this location? 16. Everything is positive, right? If you're counting steps, everything is positive. And then from negative 25 to negative 18, how many steps have you taken to go? 7, right? We don't do negative 16. We don't do 16 and negative 7 or anything like that, right? Every step you take is considered positive. So now you just count how many total steps have you taken? 16 plus 7, 23. That's your distance. Okay, so if you visualize yourself taking steps between different points, I think that's the easiest way to do the problem. You can visualize it. Let's do part J. That's the easier one. Is the speed increasing or decreasing? How do we do increasing, decreasing speed? Compare the signs. And acceleration. Yep. So we find velocity at 4. Which is positive. We find acceleration at 4, which is also positive. So therefore, speed is what? Speed is increasing, yeah, because velocity and acceleration have the same signs. What if this was negative 15 and negative 18? Still increasing, still same signs, right? If one is positive and the other is negative, then speed is decreasing. Okay, previous one. Is velocity increasing or decreasing? What is this talking about? Acceleration. Another way to think about this is that you see the word increase, decrease. Think about this as the slope of velocity, right? Increase, decrease of velocity. So if I think about, oh, my slope of velocity, that's derivative of velocity, that's acceleration. So this is describing not velocity, not position, but acceleration, and just acceleration. The tendency is sometimes students want to compare signs here as well because the wording is so similar, but there's a distinction between speed increasing versus velocity increasing. So since acceleration is a positive 6, velocity is therefore increasing. Acceleration is the slope of velocity. So my slope is positive, so therefore my velocity is increasing. Okay, any questions? All right, I have one more up here on the board. This is the one that we practiced near the end of class yesterday with the same type of problem where we have to go through power rule. So we can find a notebook paper to write this on, or you can grab one of my scratch sheets that's on one of the shelves. Number 5. Find f prime. The function is 2 times cube root of x times x squared plus 1 quantity squared, all divided by 5 square root of x cubed. This may be a little bit more complicated than we're going to see on the quiz, but I feel like if you can do a hard one, then you should feel good about an easier one on the quiz. Okay, first things first, I'm going to ask you to do power rule, so no quotient rule here. All right, first thing, we can expand. So that numerator takes some work here. We have to expand that x squared plus 1, write that binomial out twice, rewrite your radicals as a rational exponent. This is x to the 1/3. X squared plus 1 quantity squared. It's same thing as x squared plus 1, x squared plus 1. If I expand that out, I get x to the 4th plus x squared, which is plus 2x squared plus 1, all over 5x to the 3/2. Okay. Do I want to point out, do you see the distinction between x to the 1/3 versus x to the 3/2? Right there. We always read from right to left. If there's a missing number on the right side, then it's a 1. If there's a missing number on the left side, the root, that's a 2. And as I distribute, we're going to be adding exponents, right? So 1/3 plus 4, that's the same thing as 1/3 plus 12/3. Right? 1/3 plus 2, right? We multiply coefficients, but we add exponents. 1/3 plus 2 is the same thing as 6/3 plus 1/3, which is 7/3. And then 2x to the 1/3 times 1 is just 2x to the 1/3. So our first goal is just to split up into smaller problems, smaller independent problems, rather than staring at one large fraction. Now we've gotten this down to 3 individual problems. All right, we're still not ready for calculus. We're still not ready for power rule. What else needs to be done? What's out of place? Denominator, just the variable, right? The 5 is okay. The 5 is going to stay below. We're not going to bring the 5 up. We're just going to bring the x up, right? And the way we bring the x up is we subtract exponents. But this is a little messy here because 13/3 minus 3/2, we need to find another denominator, a 6, right? So 6 is going to be our common denominator. So 13/3 is same thing as 26/6. 3/2 is same thing as 9/6. So 26/6 minus 9/6. It's going to be 17/6. And at the same time, I'm also making sure that I'm pulling out that coefficient so it doesn't get in the way of the variable. It just feels like a number in front. 7/3 minus 3/2 is the same thing as, again, 6 is my denominator. So 14/6 minus 9/6, which is 5/6. And then 1/3 minus 3/2 is 2/6 minus 9/6, which is negative 7/6. So we haven't done any calculus, right? All the hardest part is just to get to the point where we can apply power rule. So this is now our starting line, and our next step can be power rule. Okay, I want to make sure that if you have any questions that I can answer it, because this is the hardest part is to get to this step. Okay, now that every term is cleaned up, no variable in the denominator, no parentheses, no radicals, we're now ready to do power rule. So we're going to bring each of the exponents down in front, and we're also going to subtract 1 from the existing exponent. So 17 over 6 comes down. Subtract 1 from 17 over 6. That's the same thing as minus 6 over 6, which is 11 over 6. Bring down the 5, 6 down. Subtract 1 from the exponent. 5, 6 minus 6 over 6 is negative 1 over 6. The negative 7, 6 comes down. Negative 7, 6 minus 6 over 6 is negative 13 over 6. And now we have our derivative. The rest is just clean up. We're going to multiply our coefficients. If you multiply your coefficients and if you don't reduce, that's fine. I'm not going to be picky about whether you reduce your fraction. I just want the negative exponents back down to the denominator. So here I reduced to make it 17 over 15. But you can have 34 over 30, that's fine. You could do 20 over 30, I reduced it to be 2 over 3. You could have negative 14 over 30, I made it negative minus 7 over 15.
But you have to change your common denominator on 1. Do you have to change it for all of them?
It depends what it was needed. Yeah, it just so happens that all these share a common denominator of 6, but that may not always be the case.
Like if you left it as 3 for the other 2 terms of 4x and 2x, would that still be fine or not?
Say that again.
Like if I left the exponent, like if I left it as like 4x to the 7th over 3.
4x. Oh, right here.
Yeah, and 7 converted to 6. Oh.
Well,
Yeah.
well, we need to in order so that, I mean, if you can do it in your head, that's fine, but I did it so that you can kind of see why it ends up being 5, 6.
Oh, all right, yeah.
17 over 6 right here.
Mhm.
So this is my current exponent. I brought the exponent down, and then I subtracted 1 from the exponent. So power rule, bring exponent down and subtract 1. Okay, that's everything on the quiz. If you have any individual questions, let me know, but if you feel good about what we did, you should feel good about the quiz. Let me know if you have any questions.
How do you get? For example, 7 for the second term, the 2 over 30x.
Oh, this is 1 over 6.
How'd you get 1 over 6?
Because I don't want a negative exponent in the answer, so I want to push that x down to the denominator. So when that x comes down, I need to change that negative to a positive exponent.
When I,
If you had it as 20 over 30, x to the 1/6, that's fine as well. You don't have to reduce the fraction, I just reduce the coefficient. Yeah, I'll give you the whole, well, yeah, I'll probably give you the whole period to work on the quiz. It won't take the full period. It's shorter than the review, but maybe I'll give you 5 minutes at the beginning of class just to look over your notes before you take the quiz. You. Sure. Because if I do,
I didn't think you guys looked over and
I gotta add exponents. So to add exponents, I got, this is really real. I can make this 6/2. Oh, no, so that means that I'm gonna add exponents.
And then so it's the subtraction for that.
Yeah, so I just did that to show how I got to that number, but that -2/2 is not part of it.
Okay,
We can replace that.
okay,
Yeah, that's not part of this.
Okay, and then, will you specify, like, if it's on the quiz where we need to use power rule for a fraction, or do we?
Just this one, yeah, so just this problem, I'm gonna specify that you use power rule.
Okay,
Everything else, you're gonna have to decide on your own,
okay, all right, thank you.
but they should be obvious.
Okay.
I haven't, so I think
Product rule is where it's like, F prime times T, I think that's the last one, yeah.
Okay.
Right there, you're back.
Product rule, yeah, it's over the fraction, right?
And then our test next Friday.
Okay. I should be free by then,
Okay.
but like, go take that one, by the way. Okay. I don't know, when I figure out like what it's like the minds, yeah. Okay.
How long is this?
Probably, maybe just like 2 weeks. It's really for process, so like I can't like. Yeah, not go on.
Yeah. I don't want to fall behind.
Thank you.
Okay.
Otherwise,